Imagine combining multiple AI chatbots into one powerful AI agent, capable of performing multiple tasks seamlessly. Well, in this tutorial, we will explore exactly how to do that using LangGraph and LangGraph Studio. Hi everyone, my name is Lode and I'm a solo entrepreneur on the journey of building my own AI startup called Parrot. Throughout my tutorials, I'll take you along as I discover and use AI tools that help me build solutions for clients. In today's video, I will walk you through an implementation of an AI agent that can serve as a lead generation tool. More specifically, we will build an AI agent that can be used for companies selling solar panels. This agent will provide information to the user as well as help the user to compute their potential energy savings. So if you're interested in learning how to implement an AI agent using LangGraph, then definitely keep on watching this tutorial. Now let's take a moment to understand how LangGraph works and how we can use it to build an AI agent that calculates solar panel energy savings. LangGraph is essentially built around the idea of graph structures, where you define workflows using three key concepts: nodes, edges, and state. First, let's discuss about nodes. You can think of a node as individual tasks or actions that the AI agent performs. In our solar panel example, each node could represent a different step in that process, like collecting user input or performing a calculation. For instance, one node might gather the user's monthly electricity cost, and another node could calculate how many solar panels they'd need based on that input. Nodes are the building blocks of our workflow, and each one represents a piece of logic or computation. Next, we have edges. If nodes are tasks, well then edges are the connections between them. Edges define the flow of the process, determining how the AI agent moves from one step to the next. In our solar panel example, an edge might connect the node where we collect the electricity cost to the node where we perform the energy saving calculation. The edge controls the flow between these nodes, ensuring that after we get the user's input, we move directly to the next step, calculating the savings. Edges also allow for conditional logic. For example, if the user provides a valid electricity cost, we move forward in the process. If the user input is missing or invalid, we could loop back and ask for it again. Lastly, we have state. State is like the memory of the AI agent. It holds all the information gathered and processed as the workflow moves from one node to the next. In our solar panel agent, the state might store the user's electricity cost as soon as it's provided. As the AI agent moves to the next node, it will carry that data forward so it can be used in the calculation node. The state ensures that the AI agent can maintain context and make decisions based on the information gathered earlier in the process. So to summarize, nodes represent the individual steps the agent performs, edges define how those steps are connected and in what order they happen, and state is a memory that tracks information as the workflow progresses. In our solar panel example, the flow might look like this. First, the AI agent collects the user's electricity cost in one node, stores that data in a state, then uses it in the next node to calculate savings, and finally the result is returned to the user, all thanks to the edges guiding the workflow from one task to the next. So that's the basic principle of LangGraph, and with it you can design complex, adaptable AI agents that handle a variety of tasks. Now we can dive into our code and see how it's implemented. So this is our project in Visual Studio Code. I have here all the Python code for the AI agent in one Python script called agent.py. The first part of the code is obviously importing all necessary dependencies, which you also need to download. For this, I usually create a virtual environment. The first part of the code will define some functions, and first of all, we will start with our function to build our tool. Our tool, which, as mentioned before, will be able to compute or predict the number of solar panels that a client would need, the installation cost, and the estimated savings over 10 years. As an input, this function has the monthly costs. So this is what our AI chatbot will obtain from the user. There will be a conversation in which the AI model is able to extract the monthly cost of the user, and this is then used as an input for the function calculate solar savings. This function has some assumptions on the cost per kilowatt, the cost per watt. So these are some assumptions and computations that I've created using ChatGPT. Of course, if you're working together with a solar panel company, then they will be able to provide you with better estimates and computations, I would assume. Anyways, using all these computations, we obtain the number of panels, installation cost, and the savings over 10 years, which is then returned as an output. Next, we define two utility functions that are used to handle potential errors that happen with a tool. This is code that is provided by the Langchain tutorial. So basically what it does, for each tool node, so for each tool that you have, in our case we only have one tool, it will create a node that is capable of handling errors. So there is basically a fallback functionality that makes the AI agent rerun the tool. For that, it uses the handle tool error, which takes as an input the state of the AI agent and adds a message that the AI agent should retry and try to fix the mistake. Next, as we have defined our tools and a fallback mechanism to circumvent any issues that happen with the tool, we can define our state. So the state of the model, as explained before, is basically a dictionary where you keep the messages sent by the user and by the AI. And this state, or this collection of messages, goes through the different nodes and edges, and in this way keeps track of what has been happening within the AI agent. So here we define a class, which is a dictionary containing a list of messages. Okay, next we create the assistant class, which is responsible for running the AI agent, interacting with tools, and managing the flow of the conversation. So this assistant invokes the tools, reprompts any errors that appear during the tool execution. Its core functionality lies in invoking the runnable function, which defines then the process of calling the large language models and the tools such as the compute savings tools that we defined before, and then monitoring the results. So if the agent would fail to return a valid response or a tool doesn't provide meaningful data, the assistant will reprompt the user or request clarification. And here you can see that there's kind of a continuous loop through the runnable until a valid output is obtained. Of course, we also need to define a large language model, which will be used by this assistant class to reply to the user and to interpret the results. And for this, we'll use Anthropic's Claude 3 model, more specifically the Sonnet model, which we will invoke using AWS Bedrock. So as you can see here, to be able to invoke AWS Bedrock, we need the Bedrock runtime client, which we invoke using Boto3, and then we use Chatbot to invoke the Claude model. So here you can see that we define the large language model by running the create Bedrock function using the Bedrock client. Next, we also have a prompt that we give as input to our system where we provide context to the large language model. So here we say that this model is a helpful customer support assistant for Solar Panels Belgium, and that their goal is to provide information regarding the monthly electricity cost. If you're not able to discern this information, ask them to clarify. Do not attempt to wildly guess. And then, of course, after you're able to discern all the information, call the relevant tool. Next, we will create a list of all our tools. So on the one hand, we have the compute savings tools. On the other hand, there is also a tool that allows you to do web searches, which is the Tavili search results tool. This is very useful if you also want your AI agent to be able to answer to random questions. For example, the question, who is Elon Musk, or whatever. If you wouldn't have this search results, there wouldn't be a correct answer to provide the user which just seems a bit weird for an AI agent, of course. And then next we combine this prompt with our large language models and our tools, which is done by this expression here. So we have our tool, we have our prompt, which is this one. We have our large language model that we obtained via AWS Bedrock, and then we have our list of tools. So this combines the three together. Now we will define our graph. So what we will do in the next couple of lines of code is combining the node, the edges, and the tools. We initiate the graph with this function, and then we will add nodes. First of all, we have our assistant node, which is the main node that will start the conversation with the user and directs them to the right tools. So this is the assistant class, and this is the runnable that we defined here, including large language models and the tools. Then we add a tool node, which includes all the tools that we defined before. So this is on the one hand the compute saving tools, but on the other hand also the Davidi search results tool. Then we need to link our nodes using the edges. So we will start by adding an edge between the start of the conversation and the assistant node. Next, we will have a conditional edge between the assistant node and the tools condition. We make it conditional because we want the model to check whether we have information to call our tool. So for example, we first need the monthly electricity cost before we can go to the monthly cost savings tool. And then we also have an edge between the tools and the assistant, so that after calling one tool, we go back to the assistant and we are able to re-invoke another tool or the same tool. Then we also need to include memory, basically to save our state. And then we can finally build our graph. So I know this code seems quite abstract and hard to grasp when you first see this. And I don't think I'm the only one, because LangGraph, they built a visualization tool for their LangGraph code, which they call LangGraph Studio. Currently, it's only available on Mac OS. So if you have an Apple laptop, then you can download it. And basically, this allows you to visualize your agent. I will come back on how to set this up in a minute, but I first want to show you how this code that we just walked through is visualized in this LangGraph Studio, which is really a great help when you're developing such an AI agent. So here you can see our AI agent that we just defined. As you can see, we have the start and the end nodes, and then we have the two nodes that we defined. So we have an assistant node and a tools node. This tools node on the one hand contains our compute savings function, on the other hand also the Davidi web search. So let me pull up the code next to this visualization. Okay, here we have it. So first we defined two nodes, the assistant node and the tools node, which you can see here indeed. We also have a start and an end to our agent. And then we defined edges. First we defined an edge between the start and assistant, which you can see here. And then we defined a conditional edge between the assistant and the tools, which you can see here. It's a conditional edge because it has a dotted line. And then we had an edge between tools and assistant. So this is really practical to be able to visualize what you have defined here. We can also test our agent here. We do this by clicking on add message, and then we can send a message. So we will start by saying, hi, welcome to Solar Panels Belgium, because this is what we provided as context in our system prompt. How can I assist you today? So say that we want to know what solar panels exactly are. We can ask that to our assistant. What are solar panels? We can submit it, and then we get some information about solar panels. And what is also very interesting to see here, that he asked whether we're interested in the benefits and cost savings of solar panels. So let's say yes, I am interested to know my cost savings. Then he will come back to you saying that he needs a monthly estimate of our electricity bill. Okay, we can provide it by saying 100 euros. And now he has the information to call our tool. By knowing the monthly cost, he's able to invoke our tool compute savings. And here you can actually see the intermediate step. This is something that you won't see when you put your agent into production, but here for developing it's very convenient, because you can see the installation costs, the savings, and the number of solar panels which were computed using our monthly cost that was provided. And then he writes it very nicely. He says, yeah, you need 10 solar panels. Your installation would cost 5,000 euros. You can save 7,000 euros over the next 10 years. So that is very useful. And then I want to showcase to you the second tool that we are using, which is the web search tool. So say that I ask information about Elon Musk. Then he says, yes, I will look up some information about Elon Musk, and you can see that he calls the Tavili search results JSON. He browses to tesla.com and then provides all the information about Elon Musk. So as you can see, there's always the two tools and the assistant. The assistant gathers information to call the tools and then actually calls the tools. After calling the tools, your back returns to the assistant, and that loop goes on and on and on. And that already brings me to the end of this video. In this tutorial, I gave you a clearer insight into LangGraph and LangGraph Studio and how you can use it to build your own AI agents. If you want to dive deeper, I will share with you my Medium article in the description below. As always, feel free to leave any thoughts or questions in the comments. And if you like this video, then definitely like, share, and subscribe for more AI insights and tutorials. I hope to see you next time. Bye!